Hello everyone, in this video let's discuss about the series voltage regulator in the electronic subject. If you see here, this is the circuit which we will be using to explain series voltage regulator. So it may be asked in the theory examinations in engineering. You can write whatever I write in this board. If you see here, in the input side, I will call it as V in, and this voltage which I am taking as an input will be the unregulated DC voltage. Unregulated DC voltage. So DC means direct current voltage. Now this is the resistances. Same resistance will be flowing here, and Q will be the transistor that I will be using here. Transistor. And I will be using the common base configuration of the transistor. So the current across the common base will be IB, and here it will be IE and IC. Means the base will be common between the collector and the emitter. So the voltage across the collector and base junction will be VCB. Next, the voltage across the base and the emitter junction will be VBE. And here we are using a Zener diode, so it will move from plus to minus. That is, current will move from plus to minus IZ. IZ means Zener current. Here I am using the load resistance RL and output voltage V out. Here V in, which is the unregulated DC voltage, after regulation V output we will get. So what will be the formula for V output? V output will be equal to VZ. VZ means voltage across the Zener diode minus VBE. VBE means output voltage. Voltage at the base emitter junction. Now Q only operates in the active region, that is, transistor Q only acts in the active region, because this transistor is a current control device. Current control device. So this transistor will control all the operations of the series voltage regulator also. Now Q and RL, that is the transistor Q and load resistance, are in series. When both of these are connected in series, this causes more power dissipation. Power dissipation. So due to this power dissipation, short circuit will happen, and here in the series voltage regulator circuit, there is no protection for the short circuit. So this is the major disadvantage. And another is, as the temperature increases, output voltage varies. So they said output voltage will vary, whether it may increase or may decrease. So let's see the two conditions also. When my output voltage will increase, and the second scenario is when my output voltage will decrease. So the formula for the output voltage is here, and we also know that the Zener voltage will always be constant. Zener voltage will always be constant. So you can tell that V0 will be directly proportional to minus VBE, or you can also tell that V output will be inversely proportional to VBE. So inversely proportional to VBE. So you can tell that when output voltage increases, VBE, that is voltage across the base emitter, will also increase. In this situation, when the output voltage decrease, the VBE, that is voltage across the base emitter junction, will also decrease. Now let's see the current. Since we are using the common base configuration, IB will be the main current which will be used. Since VBE is increasing, IB will also increase. Since VBE is decreasing in the second scenario, IB will also decrease. Next, since the transistor is a current control device, when the output current will increase, the input current will also be increased. When the output current decreases, the input current will also be decreased. That is, they will be in the same scenarios. If you see here, IB is my output current. IB is my output current. it is increasing, here it is decreasing. Therefore, my input current IC will also increase, and here in the second scenario IC will decrease. Because both the input and output current will be in the same scenario. If increase means both will increase, if decrease means both will decrease. Next, voltage across CB, that is collector base junction, will decrease. Since the input current is increasing, voltage will decrease. That is VBC, or you can write it VCB. Same. VCB, VBC will be same. Let's write VCB itself. VCB will decrease, VCB will increase. So this is the only scenario which will be opposite. All others will be same. That is VBE, IB, IC will be in the same direction. If they increase means all will increase. If they decrease means all will decrease itself. So this much if you write in the exam, you will get full marks in the series voltage regulator. So hope you understood the concept. If you have any doubt regarding this topic, please do comment below. If you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.